Let's talk today about how we find the determinant and the inverse of a 3 by 3. So a 3 by 3 matrix, right? We know what it looks like. So here's a quick way to find the determinant. This is one way, okay? It's the formal like definition way here in the box up here. But there is a very quick way to do it. So here's the quick way to find the 3 by 3 determinant. Reproduce the first and second columns. So you see how here you have that first column and the second column. You copy those over here. All right, just clone them over. I'll do an example. Then you find the products of the numbers on these black diagonals, okay? And you add them with each other. Then you find the products of these numbers on the red diagonals, and those you subtract them, and voila, you've got your determinant. Okay, let's just do one before I take questions. Okay, here. All right, so here we're going to reproduce these two and we're going to put them here. Okay, now you make your arrows. All right. Sorry. You always start with the main diagonal. It's not called the main diagonal for nothing. Like, it's because it's like the VIP of a matrix. All right. So you start with the main diagonal here. And that's what? 3 times -1 times 5, that's -15. Now you're going to do plus this diagonal next to it, so that's 4, plus this diagonal, which is 0. Okay, now the rest, I'm going to subtract them. So here's how I do it. I put the minus sign first, then I go to the matrix to collect numbers. This diagonal is 0, minus this diagonal, 2 times 4 is 8, times 3 is 24, minus this diagonal, -10. Okay? And then you add these all up, and you get -25. So the way you write it is, determinant of A is -25, or determinant of A is -25. Okay? Yes? All right. Yeah. Calculator. In the calculator mode, you're going to go to menu. And look, number 7 says matrix and vector. All right? So you hit that. And in this menu, you're going to do create, number 1, matrix. All right? Number of rows, 3. Oh. Number of columns, 3. What?
Yeah, that's what you press tab.
You have to press tab. Okay, enter. And there you have it. So let's put these numbers in. 3. You have to do tab. It's a little bit easier. So 3, 1, 0. So if you keep pressing tab, it goes through the entries horizontally. -2, -1, and 4. Tab. And then 1, is it 1, 2, 5?
Yeah.
Okay. So now you have to go back to menu. Back to 7. And here, all right. So, okay, so you can find determinant, or you should be able to find inverse as well. There was a, okay. All right, so if you want to do determinant, so what you could do is, you could, do you know how to control C and Control V? Like, do you know how to copy?
You can press up.
Okay, so look, so here's what you could do. You could press up and enter, right? That's one way to do it. Determinant is that one, negative 25. Now, what you could also do is go up, 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 grab your matrix, okay, highlight the matrix, enter, and if you want to find inverse, we're going to do to the power of, and we're going to do -1, and that's your inverse. Okay? Yeah. It's very unsatisfying, ungratifying for me because I don't, it's so much fun to do it by hand, but we just don't have the time to do it.
How do you do it?
You just do the matrix to the power of -1. Okay, so then, you're going to copy it over. I'm always going to want these in fractions, so just keep that in the back of your mind. All right? No. Yeah.
When you're multiplying, it would be like this part, like that part.
Question?
Yes, do you know how to get
Tuesday. Definitely Tuesday. Okay. No. Okay. So take a look. If I have 6x is equal to 18. If I have 6x equal to 18, and I want to solve this for x, if it's 6 times x equals 18, what do I have to do? Divide by 6, divide by 6, and x is equal to 3, okay? So it's 18 divided by 6, it's 3, okay? Now, if I have the same sort of situation, but with matrices, now they're all matrices. So for example, I have a matrix A, okay, times a matrix X equals another matrix B, right? So look at what I had here. A number times a number equals a number. A number times an unknown number equals a number. Here I have a matrix times an unknown matrix equals another matrix. Okay? So, theoretically, wouldn't it be cool if I could just divide by matrix A, divide by matrix A? But we just said we can't divide by matrix A.
So you multiply by A inverse?
What you could do though, look at this one. Yeah, I divided by 6, but technically, right, I multiplied by the inverse, the multiplicative inverse of that. So what I could do is to find x, I could say A inverse, not A plus, A inverse times B. All right, that's dividing. Don't ever get caught saying divide by a matrix. That doesn't happen. You can multiply by the inverse of a matrix. So solving, okay, so in this chapter, it's all about solving a system of equations. We learned one way, and that was the, Gaussian elimination. Now, the second way is solving using inverse matrices. Then we're going to learn solving by Cramer's rule, and so on and so forth. And so on a test, for example, it's not just solve the system of equations. I want to know, do you know each of the methods? All right. So today it's the second way that we're going to solve it. Yes, absolutely. You'll have one where I say do it whatever you want, however you want, and then I will definitely ask for the specific ways. Okay, so what we do if you want to solve a system of equations is we rewrite the system in matrix form, and that's A times X equals B. So basically that's the coefficients times the variables equals the constants. You find the inverse matrix, and then you multiply A inverse B. Okay? of course, it has to be in that order because multiplication is not commutative, right? Okay. Of matrices. Yeah.
When it says like find the inverse, that is also used to find the determinant as well.
Yeah, yeah.
But you said that the way that we did it for the 2 by 2
Is different, right?
That's
Unless you have a calculator. Yeah. Okay. So use an inverse matrix to solve these. All right. So first we have to write it in terms of matrices like this. Okay. So here's how it's going to work. We're going to have here the coefficient matrix. That's 2, -3, -3, 5. Okay, that's the A matrix. Then in the X matrix, we put our variables. In our case, the variables are X and Y. Then I have my B matrix, -1, 3. Those are the constants here. Okay? Now, let's pause for a moment and let's see what exactly is it that we've done here. Look at the A matrix. What are the dimensions?
2 by 2.
2 by 2. What about the X matrix? 2 by 1. Thank you. Can those two be multiplied?
Yes.
Yes. And when you multiply them, what dimensions do you get? A 2 by 1. So potentially I can multiply those two matrices, right? You know what? Let's just multiply one. Let's multiply the first row with the first column. Okay? What do we get? 2x minus 3y. 2x minus 3y equals what? -1. You see how it's the same exact situation? Let's do the second row. -3x plus 5y equals 3. -3x plus 5y equals 3. You see how it works? So this and this are the same. Okay, now, so that's what we have to solve. In order to solve this then, I need to find A inverse. So first, let's find the determinant of A, and that's 2 times 5 minus -3 times 3, whatever, it's just 9. Right? So the determinant is 1. I love it when the determinant is 1. It makes things so much easier. Huh? Okay. So A inverse is 1 over that determinant 1 times, okay, the main diagonal switch seats, so 5 and 2. The other diagonal just change signs, 3 and 3. So A inverse is just 5, 3, 3, 2. Well, they were negative and they flipped signs. So to find an inverse, the main diagonal, they switch seats. These stay where they are, their signs just switch. You just multiply them by negative. Remember? From section 2. So now we have to do this. XY is equal to the inverse times B. Okay, so this is X equals A inverse times B. It's amazing. It's fantastic. This is my favorite branch of mathematics. This is linear algebra. This is like day 1 of linear algebra class. And then, you know, like, this is my favorite branch of mathematics, I have to say. This and differential equations, but okay. So, 2 by 2, 2 by 1, what am I going to get? A 2 by 1. So, in the first spot, I get this and this, -5 plus 6, plus 9, which is a 4. And then I get -3 plus 6, which is 3. So my answer, look at what this says. X is 4, Y is 3, so it's 4, comma 3. Yeah. Okay, so Kramer's rule is now the third way of solving matrices. It has nothing to do with the first and the second ways. Okay? Kramer, obviously, it's named after Kramer's rule. So this one, the good thing about this is you don't have to deal with inverses or anything else. You just have to deal with determinants. It's very, very straightforward. Okay? And there are different ways of doing it, but we'll stick to this one. I feel it's more straightforward. Okay, so how do you solve a system using Kramer's rule? You have to find the determinant of the coefficient matrix. Okay, we now know what the coefficient matrix is. And then there is a little bit of replacing that happens. You replace each column by the constants column to find the determinants. Okay? And then you have to divide each of the determinants by A. Okay, so obviously none of these make sense unless you do one, right? Okay. Take a look at this. We always use XYZ, right? And that's cool. And then if like, you know, we're daring enough to have 4 variables, it's WXYZ. But then if you have more unknowns, it doesn't make sense to have all these like variables, right? Like if you have 7 unknowns, then you're going like further and further back, and then like it doesn't make sense. So instead, scientists and mathematicians, they would rather just do x1, x2, x3, x4, x5 instead of XYZW, right? So instead of XYZ, why don't we just do x1, x2, x3? Like, what difference does it make what you call them? You could call them XYZ, you could call them banana, pineapple, apple, whatever, right? Like, it doesn't matter. It could be happy face, emoji, whatever, okay? So I left this way on purpose so you get some exposure on to this stuff as well. Okay, so but x1 and x2, it's just like x and y, and you don't even have to, you know, think about like when you get to like the 7th letter, which one comes first in the alphabet or whatever, right? Okay, so what's the coefficient matrix? We call that A, and that's just going to be the coefficient matrix. So we're going to have 4, -5, -3, and 2. And remember, that's the x1 and the x2 column. Okay, now go ahead and find the determinant of A. Anybody? -7. Okay. Should we do it together? Okay. Now here's what we're going to do. We're going to come up with this matrix AX1. Okay. Okay, determinant is this minus this. So that's +15, right? Which is -7. When we have to find the inverse of A, that's when we do 1 over the determinant. Determinant is just this though. Now we have to come up with this matrix called AX1. Okay? AX1 meaning the matrix that belongs to that column, to that variable.
So is the axis subset?
Yeah. The way in which we write that is this. I take the coefficient matrix A And if this is the X1 matrix, I have to replace the X1 column by the constants. Okay? So, again, this is the X1 matrix. So you replace the X1 column's coefficients by the constants. The other one stays the same. Okay, so I'm modifying this. I'm just replacing the X1 column. Okay, while we're on this, let's do AX2. I'm going to take the A matrix and now replace the X2 column by the coefficients. Okay. Oh, I copied from above. 4 and negative 3. Okay, now let's find determinant of AX1. That's going to be negative 49 times 2 minus 28 times negative 5. How much? So now AX2 determinant is 4 times 28 minus 3 times 49. That's negative 35. So far I've done nothing to solve for X1 and X2. Now comes the good part. That variable X1 is just determinant of X1 over determinant of A. So 42 over negative 7, negative 6. And then X2 is the determinant of X2 over the determinant of A, negative 35 over negative 7, 5. Then, that's it, we're done. Negative 6 and 5. Let's do this one by Kramer's rule again. So, you have the coefficient matrix. Here, x is 0. So it's 0, 1, 4. All right. And then 2, negative 2, 1. 1, 0, negative 4. Okay? Let's just write down all the matrices first, then we'll do determinants. Okay? All right, now we're going to find A sub x because we have, you have 3 variables, x, y, z. So after the coefficient matrix, you have to have 3 different matrices, ax, ay, az. Ax, I'm going to replace the first column by my coefficients. 1, negative 18, 7, by the constants. Oh, it is negative 1. So then I have 1, negative 2, 0, 4, 1, negative 4. Okay. Then AY, I'm going to replace the middle column. Okay. AZ, I'm going to replace the last column. Okay. Why don't we use our calculator to find the determinants here? I mean, you should know how to do it both ways, right? So if it's on the calculator section, use your calculator. Don't do it by hand. Okay. So look at what I'm going to do. I'm going to bring this thing back and just Try to revise. I wonder if it's easier than creating a new one. What happened here? I think it is easier to. So the determinant of A is 17. Make sure you put those bars around it. Okay, so then for the next one, I think it's easier to just edit, right? I went up, so I pressed the up button until that's highlighted and just press enter and it just brings it back for you. So what is this? -1 and -18. And how much is this? 7. So you get -17. Yeah. Okay, and now you need to do the same thing for AY and A. So 119. So now X is -17 over +17 is -1. Y is 119 over 17, 7. Z is -34 over 17, -2. So, -1, 7, -2. Isn't that cool? Okay, we'll stop here. And so this homework will be due Wednesday, actually, after the quiz, all right, because I want to finish that first. I got 17, and I got 17 last year too. Tuesday I'm collecting these, so grab your stuff to staple.